square if r1 and r2 are the roots of 2x square minus 4x minus 12. And the solution before this, what's this type's question? This is quadratic question. If let's is ax square plus bx plus c is equals to f of x, then a is the coefficient of x square a, the x coefficient b, and the constant term is c. Under this, Whitehouse theorem says Whitehouse theorem, we have two theorems. The first one, the sum of two roots r1 plus r2 which is equals to minus b over a, coefficient of b and the coefficient of a. And the second, r1, the product of the two roots, r1 times r2, which is equals to c over a. Then how we can calculate 4 over x over r1 square plus 4 over r2 square. Under this, we have 2x square minus 4x minus 12. Under this, a is equals to 2, where b is equals to minus 4, the coefficient of x. c is equals to negative 12. And we have the formula r1, the sum of the two roots r1 plus r2 minus b over a. The product of the two roots r1 times r2 is c over a. Then r1 plus r2, which is minus b over a. Under this case, what's b? b is minus 4, minus negative 4 over the coefficient of x square is a is 2, which is negative positive 4 over 2, which is equals to 2. The product, the sum of r1 plus r2 is 2. And the next, r1 times r2 is equals to c over a. c is minus 12 over is 2, which is negative 6. r1 times r2 is negative 6, and again r1 plus r2 the whole square, which is r1 plus r2 times r1 plus r2. When expand this, r1 times r1 square, r1 times r2 plus r1 plus r2 times r1 times times R2 plus R2 times R2 square. Then collect like terms R1 plus R1 times R2, R1 times R2, twice of R1, R2, which is R1 square plus 2 times R1, R2 plus R2 square. Then R1 square plus R1 plus R2 the whole square which means R1 square plus R2 square, R1 R2 plus twice of plus R2 square. R1 plus R2 is R1 plus R2, R1 plus R2 is R2, R1, R1 plus R2 is 2, then R1 plus R2 is 2, this 2 square is equals to R1 is unknown plus 2 times R1 times R2, R1 times R2 is minus negative 6, negative 6, negative 6, negative 6, R2 square is unknown again. 1, 2 square is 4 equals to R1 square minus 2 times negative 12, negative 6, 2 times negative 6, negative 12 plus R2 square. R1 square plus R2 square is required. Then add 12 both sides. 4 plus 12 R1 square minus 12 plus 12 plus R2 square. R1 4 plus 12 is 60. R1 square minus 12 plus 12 is 0 plus R2 square. 4 plus 4 16 equals to minus 12, negative 12 plus 12 is 0, R1 square plus R2 square, which is 16. We have this R1 square plus R2 square is 16. As the remains, the required is 4 over R1 square plus 4 over R2 square, which means the LCM of R1 square, R2 square is the product, R1 square times R2 square. Then R1 square, R2 square divided by R1 square is R2 square, or 4 times R2 square, 4 R2 square plus 4 times R1 square, 4 R1 square. And simplify this. The common factor is 4 into r1 square plus r2 square over r1 times r1 square times r2 square. Then substitute the value of a given r1 square plus r2 square is r1 square plus r2 square is 16. So substitute r1 square plus r2 square is 16. Then which is 4 times r1 square plus r2 square is 16. 4 times 16 over r1 square, r1 times r2 the whole square, which is r1 times r2, r1 times r2, r1 times r2 is negative 6. r1 times r2, negative 6. Then substitute r1 times r2, which is r1, r2, r1, r2 the whole square. You can write this r1 square, r2 square. You can write as r1, r2 the whole square. So substitute this equals to 4 times 16 over r1 times r2 is 6. 6 square, negative 6, negative 6 square. Which is 64 over 36. Or by 4, 16 by 4, 9. Therefore, r1, 4 over r1 square plus 4 over r2 square, which is 64 over 36 or 16 by 4 by 4, 16 by 4 divided by 4, 9. Answer is this.